So what would fx be?
Plus 3y squared.
And what would fy be?
6.
I like 2, 3. You want to make it a 6? It's a free. It's an open, free society. Do what you want to do, Jeff. Jeez. All right. And then, of course, what do you do with those?
Take the second derivative.
Yeah, but even before I do that, I want to see eventually what I'm going to want to check. Yeah, so if I look at this one, what's got to be true? X equals 0.
Oh, did you miss the directional derivative one?
I did. Y equals 0.
I totally forgot how to do it. It was so simple too.
Now I'm addressing a specific thing that I saw happen on a few people's quizzes. And I made this point before, is the easy points are miss. So what do I do with those now here? Yeah, plug them in and see what I get for y. So for example, if x is 0, which means the points that I will get from the work I'm doing will have a 0 there. Right? So I'm not even going to write them. Let's see. If x is 0, I get 3y squared minus 3, and I want that to be 0. So I get y equals... If y is 0, don't eat 0. Now, if y is... So where am I getting these from? There. Okay, I like it. So they're systems of equations, right? So I got one set of equations solved. I've got to use that solutions in the other one to see when is that also true. So y equals 0, I get something very similar. 3x squared minus 3 equals 0. So I get x equal plus or minus 1. So I get y is plus or minus 1x. Is this point mean anything to me? That point doesn't mean shit to me, right? I'm really trying to make this point. I see y is x, but when is y plus or minus 1? When x is 0. So you've got to really pay attention to where are these things coming from? What is making this other thing happen? So when x is 0, I get those 2 points. When y is 0, I get those 2 points. So there would be 4 critical points. Take my second derivatives, plug it in the crazy d thing. I like it. Okay. Anything else from that? That was a question I had that I answered myself from the quiz. Anything from the quiz stand out? No? I'm trying to make it pretty straightforward. Force Gump? Yes, okay. I could barely see the hat. I was like, well, who are you? And I don't know. No? You're not dressed up? I'm sorry. Okay. I am a sociopath because we look like everybody. I like that joke from Addams Family. They look like everyone else.
Professor?
Yes?
If the f of x, y is 3x squared minus 3xy plus 3xy.
What happened, sorry?
So that's a difference. If the form is 3x cubed minus 3xy, then that would be different, right?
Oh, if this is a y here? Yeah.
That would be different.
Then different things would happen. Yeah, I'm sorry. Yeah, I didn't understand your question. Obviously, you give me a different function. Who knows what could happen after that? Yeah.
So the f of x has to equal 0 along with the f of y.
They must be 0 at the exact same time.
Right. So if you have, like, for example, if they simplified down to x minus y and y minus x, they would have to equal y.
Yeah, it's possible to have a ridge of... It kind of makes sense. We could have these cylinders where there's a bunch of local mins, or local maxes in this case, all in a row. Sure. You could have equations that come out of this, not just points, but collections of points. Yeah. All right. I like it. All right, so anything from homework? I got this one question that I'm not going to do. I'm going to do one like it. I like that triangle. I like the triangle problem. Mike is like, oh yeah, thanks man. Oh, thank you. So this one is number 31, which is pretty much just like number 32. and 14.7? This is an absolute max-min question. So back in Calc 1, that was the easier question. Now in Calc 3, not really. A little bit harder, actually. Too bad for us, because now we don't just have endpoints, we have boundaries that are equations of who knows what. Yeah. So this one's neat. This one says xy equals x squared, y squared plus 2x. They use D in so many ways. D here is the domain. 2, 0. So the triangle with vertices 2, 0, 0, 2, and what was it? 0, negative 2. Take a second to try to sketch out that triangle. Shouldn't be too crazy. The less sketches you're making for yourself as you do homework, the less I understand you. Especially now, my God, you've got to be making sketches of everything to see what the hell's going on. We're going to be getting into triple integration. You know it was existing. You know it's there. You know it goes beyond that, but we're not going to do that. We're going to go over 15.4 a little bit. So, am I remembering correctly? Yeah, 15.4. By the way, guys, if you didn't notice, 15.5, extra credit. 16.6 we're going to do. It'll be normal credit. And it's kind of like the more general case of 15.5. So if we do this, why do that? Yeah. Oh, I didn't say this before, but extra credit, I do normally let it happen until the final, so I need to, I think there was one section I need to change in WebAssign. It was extra credit. Got to change the due date.
14.8.
14.8? Oh, yeah. Andrew, Maria. All right, guys, let me catch up to you here. What's this thing look like? It's got 2, 0, 0, 2, 0, negative 2, triangle. So I just want, now this, what does this denote? What is that all about? What is this? I like it. Surface, above or below this. So I want to know if it is above this, it'll be the true volume. If it's below it, it's sort of the negative volume, and we can handle that. So it's basically, this is the area over which I'm going to integrate. Yes? Oh, I'm ahead of myself. All right. It would be the area over which I'm integrating, but we're just finding maxes and mins. I'm thinking about what we're going to be doing later. So what do we got to do? This is like old news to me. What do we have to do? We have to do fx. 2x minus 2. And fy. 2y. You got to love that. So from this one, I'm going to get 0 for y. From this one, I'm going to get 1 for x. It's the only point that makes both of those 0 at the same time. I like it. Cool. Blah, 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 blah. All right, so and then I could, and so that's one candidate for a point that makes this the biggest or the smallest. All right, so the critical points are always a candidate, but the other candidates are all the points on these lines. Those are all of the endpoints. So in 2 dimensions, in Math 180, we only had 2 endpoints. Now I have an infinite number of endpoints. Yay! Thankfully, I don't have to plug them all in. Can somebody help me out? What's the equation for this?
X equals 0.
That's crazy. What's the equation for this? Y equals 2 minus x. And this one's going to be sort of its mirror image of y equals x minus 2. I like it. All right, that is a huge step. Sketch a graph of the region over which you're looking at. And then you have to identify all the boundaries. You have to give them all, you have to identify what their functions are. Because you're going to use that information to plug into your function. So you're specifically only looking at the inputs that are on this line. So what does my function look like now if I use this here? So f of x, 2 minus x.
Squared plus 2 minus x.
Yeah, x squared plus 2 minus x squared minus 2x. Notice how, does anybody see how that's going to be the same damn thing? Because 2 minus x squared is x minus 2 squared. That's nice. Doesn't always happen. And just to do this one here, if you do this, what do you get? You get 2x squared minus 6x plus 4, right? So I really want this. Now this is interesting. Let me see if you guys are kind of with me. Where's the vertex for this? So this green line is all about here, right? How do you find the vertex for that? Because that's going to be where what happens for this. And how does this relate to this? Yes. So I've just evaluated this function for every point on this line. I did it all at once. So that's what I mean by there's an infinite number of points, but I don't have to individually identify. I can just plug the definition of them in. So that is the same as this, just specifically for those points that are on this line. So why did the function condense so much? There's only one variable because there was a restriction now. They must be on this line. So I can get rid of one variable. That's what we did. We substituted, got rid of a variable. I like it. So what's going on then is the surface for this line, it looks like a parabola. Now if I could just have the z-axis coming out, I really want you guys to... But is this an up or down parabola? Opens up, which means there's going to be, it could be like this, sitting over that curve. But we don't know until we actually plug stuff in. So this curve tells me that the surface, if I sliced through the surface along this curve, above and below this, then that surface is looking like a parabola. Then that cross-section looks like a parabola. It's very interesting on its own. Did you really have to understand all of that to do this problem? No, but the more you understand what you're doing, the more sense it makes. So I can find the min. Where's the max of this going to occur? Because what is x allowed to do?
It's from
0 to 2. I like it. So it's going to be at one of those. Because the max of a parabola is going to be at one of the endpoints, depending on where the vertex is in the middle. All right, so what's the vertex of this bad boy here? Negative b over 2a. Do you remember that? Or you can take derivatives, that's fine. You guys forgot negative b over 2a? Little tear. If I take a derivative, what do I get? 2ax plus b equals dy dx, right? So where's that equal to 0? At negative b over freaking 2a, right? Does anybody remember that shortcut for finding the vertex? You first learned about it. All right, I'm going to have to do a whole little side note because this is too big for me to let go. What's the quadratic formula?
square root b squared minus 4ac.
Let me do it like this. So it's all right if I do it like this just to be kind of... So it's this, give or take that. So it's always in the middle. This, I mean, come on. That's too beautiful. So before you knew calculus, if you had a good pre-calc teacher, they would have shown you where the hell it comes from. Just saying, here it is. Or just not even telling you. I don't know if anybody wasn't even told about this shortcut for finding the vertex. That would be a little hard for me to believe. So you can prove it before you know calculus, but then there's calculus just kicking its ass, right? Do you guys get this? The vertex will always be in the middle of your intercepts, and it will always be that negative b over 2a. It's the give or take. So symmetry tells me the vertex is going to be right in the middle. All right, that's a very quick little thing about that. So here what's going to be? 6 over twice 2. So 3 halves, and then when you plug 3 halves in, I think I did it somewhere. What do you get when you plug 3 halves in? Maybe I didn't do it. I got bored. I thought I did, but maybe not. 9 halves minus 18 halves is negative 9 halves, plus 8 halves is negative 1 half. Okay. Now let me be careful. This is the vertex of this. Now I'm being a little bit loose here, like I always do, because it's all about the idea, not the freaking process. It's all about the idea. That negative 1 half is actually what relative to this whole problem? Oh shit. What do? We plug the 3 half in, and what comes out? The function value. I like it. So that is the output. So I already know what the value is at the vertex of this, which is this guy's minimum. What goes here, though?
The y.
Yeah, and y equals 2 minus x.
So you plug in.
So y is 1 half. Oh. So there's a candidate for minimum at this point because it's the lowest I get on this line. Now the max is going to occur at this point or this point. And if you think about it, since the vertex is at 3 and at 3 halves, it should be at this side. It should be x equals 0. And sure enough, if you make x equal to 0, you get 4. So there's also 0 comma something with z equal to 4. When x is 0, y is 2. All right, maybe. This is the kind of thing you have to do. Are you with me, Mike? Because you asked this question about number 32. This is 31, but it's exactly the same. You do all the exact same stuff. Yes, sir. Yeah. So now I still have to plug in 1, 0. The nice thing is I already plugged this in. I already know what it is. I already plugged this in. I already know what it is. Now plug this in. And I still have to mess with this guy. Right?
Wait.
Well, that
Why
guy's
are we
the same.
plugging in 1, 0?
Because what are my candidates? What are my candidates? What are my candidates for possible maxes, absolute maxes and mins? The critical points, 1, 0. And also any points on the boundaries that give me maxes and mins.
Yeah, but why are you plugging that into that equation?
Plugging what into there? Plugging what?
The 1, 0 showing you.
I'm not going to plug it in there. I'm going to plug it in here.
Okay.
Yeah. This is x, y, right?
So the vertex of that line is the critical point of that, of y.
Yeah, it's the critical point of the function strictly held
just
to
that
this
line.
line. Exactly, I like it.
Okay.
Which is not a critical point for the whole surface, because I already found all the critical points. You kind of, it's just like in Math 180, where can there be max, min, and max, and absolute max? Well, here's a local max, but there's the absolute max. And that's just because it was on the endpoint. It was the endpoint. So, it's hard to extend this idea here, but I have to check every endpoint, which means I have to check every point along here. Which one gives me the biggest and the smallest? Those are the candidates, other candidates beyond the critical points. Those are the candidates for location of max, absolute min. I like it. So what do you have to check in calculus? Critical points, endpoints. What do you check here? Same thing, except the endpoints now are collections of points that lie on lines or curves. But it's just substitution, that's all it is. If this comes out to be something funky, not parabolic, what do? Take a derivative. Find its critical point. Then you're back in Math 180. Right now we're back in Math 176. Maybe even 110. Just finding this guy's vertex. Alright. Hopeful. There are a lot of good examples in that section too. If you're not looking at those, I also don't understand you. Okay. Anything else from homework before I jump into weird shit? No.
14.7, number 56. Yes, that one.
Oh, let's see. This one sounds funky. So it says the model for the yield, Y, function of nitrogen and phosphorus. Where K is some positive constant, probably related to other factors in the environment. I'm really curious if that's an actual equation, but oh well. So yeah, now you attack it like you would, if you wanted to, you can even make these X and Y as you do the problem if it makes it easier to look at. I have no problem with that as long as the end, you bring back N and P. It's just like using a U substitution. Just in the middle, you're making it look easier. But, so they ask, what levels of nitrogen and phosphorus result in the best yield? Yeah, take the partials, right? So if you wanted to, instead you want to use this in the middle. Right? That's fine. Is that cool? You guys understand? At the end, you better bring back X and Y, or else I'd be all dorky and say, what the hell's that? N and P, exactly. Yeah, so then you take Fx. Is that cool? Did you get stuck in the middle, or you weren't sure how to even...
I wasn't sure like what I was asked before.
Oh, so it's really just saying, here's the function. It describes this thing physically. As a mathematician, we don't care. But, I'm interested in the nitrogen analysis stuff. But as a mathematician, we just say, okay, how do I make this the biggest it could be? Yeah, the best yield. So it's the most that I can get. I like it. Sounds like something a farmer would be interested in. What's really funny to me is, for example, do you know why silos are the shape they are instead of big boxes?
Gases or something? Or that's
Yeah, especially depending on what you put in there. But normally, if there's something a little that doesn't have much in the middle, then this makes the biggest volume for the given surface area. This was known before math came in and said, "Oh yeah, you're right." I mean, so I'm sure there are farmers who, before they even knew this thing existed, just kind of played with the levels, and I'm sure there's other levels you have to play with too, and they kind of got something good. And if you do the math, it'll probably come out close to what they did experimentally. I like it. But what happens, especially when you get more and more variables, so you start going to 3 dimensions, 4 dimensions, 5 dimensions, all of the peaks, you could be sitting at this peak, but if only you did some math, there's a better peak a little bit further down. You just never got there experimentally. Right? So there's some people that say, why do I need math? I figured this out a long time ago. Because math would tell you, oh shit, there's a higher peak. Just go a little bit further. Right? And now I'm talking about you can go a little further this way and a little back this way, and now there's a higher peak. Because you got multiple variables affecting your output. I like it. I like how you're all just humoring me. Sure, Jeff, whatever. Is that...
It also doesn't take anywhere near as long as it might take with...
Experimentation, exactly. You got to go over several cycles, you know. Like 8 years later, I think I figured it out. Should have got a mathematician. Well, I mean, there's other considerations here too. Yeah, you won't have the YouTube video of the runaway grain sphere, you know, rolling down the. It kind of gives it a nice solid foundation. There's other things to consider. Okay, anything else from homework before we do other things? Okay. Just to remind you guys, I'm going to give you a little thing to work on. I'm going to put some reminders up here. let's see, what should I tell you? The only thing I really got to put up here, I think, is if I want to convert to polar. Let's just say D. So if I want to convert this to polar, what happens to this? I like it. There's something called the Jacobian. Jacob? Yeah. That if you're at all curious about generalizing, we're actually going to talk about this later this semester, but if you want to look it up right now, it's a nice general way to use matrices to determine what this is going to be for any transformation you apply to your variables. This is just one specific transformation. If you use the Jacobian, it comes out to be R. The Jacobian tells you what's going to go there to make things work. We did it a little different way, right? That's just a side note. It's going to come to us later. And then what's the thing to change in here? Yeah, X is now going to be R cosine theta. R sine theta. Of course, in general, if you see x squared plus y squared, please, dear God, don't plug this in there. X squared plus y squared is r squared. Right? Don't plug r cosine theta in there and stuff. Okay, and then these will just be determined by the region. Okay, so let me let you try this out.